All right, guys, the last kinematics example problem. As an example, this time a little different. The object is projected upward. It's not falling. Now it's going upward. But again, good idea to keep our equations handy. VF equals VI plus AT. Change in distance or change in position equals VIT plus 1/2 AT squared. And VF squared equals VI squared plus 2AD. All right. Same process as always. You start with drawing a picture, but let's read the problem. A 1/2 kilogram ball is projected straight upward. So here's the ground. There's a ball on the ground. DTV. We'll call this position 0. We'll call it time 0, and is projected upward with an initial speed of 30 meters per second. Upward. It's going to go up. The ball will get to here. DTV. Determine the maximum height. We want to know what this is. Determine the time it takes. We want to know this is at its maximum height. I'm hoping you know that when the ball reaches its maximum height, its upward speed will be 0. Very important to know that the whole time. And since we can ignore the effects of air resistance this entire trip, the only force acting on it is gravity, so it will accelerate. Gravity will accelerate this thing in the downward direction. Gravity is going to cause this thing to lose speed at 9.8 meters per second squared the entire trip. There is no effects of air resistance here. All right, so now let's see. I always go to this first equation. VF equals VI plus AT. VF, the speed at the top, is going to be 0, equals the initial speed was 30 meters per second plus negative 9.8 meters per second squared times time. We want to know time. Bring this over here. Minus 30 meters per second equals negative 9.8 meters per second squared times time. Divide both sides by negative 9.8 meters per second squared. You're going to get time of just about 3 seconds. 30 divided by 9.8. Time to be 3.06 seconds. 3.06 seconds. We figured that out. Determine the time. 3.06 seconds. Got that one already to reach its maximum height. Now we want to know the distance. The distance. Here you could use either this equation or this equation. It doesn't matter. Choose. You're going to get the same answer either way. Let's do this one first. We'll do them both. VF squared equals VI squared plus 2AD. VF squared is going to be 0. VI squared, it was 30 meters per second. That's squared. Don't forget to square it. Plus 2 times negative 9.8 meters per second squared times the change in position. This becomes 900 meters per second squared, but we're going to bring it over there, so you're going to end up with negative 900 meters per second squared equals negative 19.6 meters per second squared times the change in distance. Change in distance, 900 divided by 19.6, 45.9. We'll just call 46 meters. 46 meters. Okay. 46 meters. I wonder if we used this equation, would we get the same thing? Let's compare and find out. Delta D equals VIT plus 1/2 AT squared. This way is a little more annoying, a little more math, but you're going to get the same answer. Change in distance is what we want to solve for. VIT starts at 30 meters per second upward. Its time we figured out was 3.06 seconds plus 1/2 negative 9.8 meters per second squared times the time squared, 3.06 seconds squared. 3.06 squared is that, times 9.8 is that, times 0.5 equals all of that junk. This is going to be minus 45.9 meters. 30 times 3.06, 91.8 meters. Let's see what we get. 91.8 minus 45.9 gives us, oh, did I do that right? 91.8 minus 45.9 equals 45.9. Oh, 45.9. I'm going to round again. Delta D equals 46 meters. Same. Doesn't matter which way you go about it. Double check it. The maximum, determine the time it takes, the maximum height reached by the ball. We get the figure of maximum height, 46 meters, maybe 45.9. But there you go.